Screen is visible to everyone?
Yes.
Okay, thank you, sir. So, as per the discussion with the coordinator of this PhD workshop, uh, they have invited me for the delivering lecture based on several topics that they have given. So, I am going to deliver my talk on two subtopics. These topics might be useful. So, the students that are working in the field of nanotechnology as well as material synthesis. So, before starting the lecture, I would like to tell you that this lecture is based on the synthesis of nanomaterial and several properties of the nanomaterials, as well as I'm going to explore some characterization techniques. Uh, I hope that all the techniques are not going to cover in this lecture, but two or three characterization techniques we'll try to cover in summarized form. So, I think that there are many students might not be from the chemistry background, but I am also going to talk on another topic that might be useful for those students which are not from the chemistry background. So, if there is any question, you can interrupt me in between the lecture. Thank you. So, many of the students that are from the chemistry, electronic science, and physics background are willing to complete their research in the field of nanomaterials or nanotechnology. So there are many reasons why the many students are shifting towards this topic, and what is the main interest and why people are looking towards the synthesis of new nanomaterials, exploring their applications, exploring their properties. And what are the reasons? So there are many reasons, but in short, I would like to highlight that the synthesis of these nanomaterials is quite easy as compared to the another organic synthesis or any other molecules that are people think that the material quite be difficult to synthesize in the laboratory due to different problems associated with the laboratory space or equipments, etc. But the main thing associated with the synthesis of nanomaterial is that that required very low space. They are cost effective for the synthesis, as well as comparative time to synthesize the material is very low. And the most promising thing is that 100% possibility that the materials could be synthesized in the laboratory scale. So these are the several merits, and because of these particular points, many students are switched toward the synthesis of nanomaterials. They might be from the electronic science, physics, or any other background. But we can see comparatively this topic is applicable to almost every fields. And again, I would like to highlight because all the students are uh, future doctor. Everyone is willing to take this degree. But what is the importance? And main thing is that uh, everyone wants to complete his or her degree within the stipulated time. So this is the assurity related to the synthesis of nanomaterials, and we are going to uh, explore the application in various fields. So that is quite easier. This is my opinion actually. The views of other audience may be different based on the nanomaterials, but this is the simple clarification from my side based on the topic. So moving towards the topic. So this is very basic explanation related to the nanomaterials. I am shortly going to explore the synthesis methods based on the nanomaterials. Uh, BSc or MSc students might we know that what are the nanomaterials, and everyone, if our teacher asks the definition of the nanomaterials, and we simply tell that the materials between the 1 to 100 nanometers are recognized as nanomaterials. That is correct, but nanomaterials specifically may not belong to this range. The nanomaterials or other materials that are generally classified within this category may have the different ranges. So, particularly nanoscience and nanotechnology, what is the basic difference? So, in general, we can say study of the different properties of the materials at the molecular level as well as the nanoscale level. And basically, to explore this knowledge, to design various important models or devices that are generally based on the societal application, as well as we can design some equipment based on the nano dimension. That is what the nanotechnology. So we are simply exploring these nanomaterials, their properties for the sake of beneficial of the mankind as well as for the society. Now, what is the purpose and why to study the nanometers? Because the nanometers exhibit several special properties. They have some unique properties that are also called as the inherent properties as compared to the bulk materials. And simply they are providing some kind of the potential and transformative solutions into the various scientific fields such as medicines, energy, electronic, catalysis, optical technologies, or solar cell, etc. So there are many fields. There are some examples only. So these are some examples where you can see that where these nanometers can belong. So you can see this slide, and after looking, you can see that the DNA material or ATP synthesis. So they are the natural things where the nanometers can be comprises. But here, at the same time, you can see these are the things which are man-made, like transistor, resistors, and another micromechanical, electromechanical devices. So these are man-made things, but this belongs to the nano range or nanoscale. These are some additional examples that explore the various nanometers and their categories. Their chemical synthesis methods can also be useful for designing these nanometers, as well as some natural examples, antibodies, spores of some fungi, red blood cells. So these are some natural examples of the nanometers. So what are the unique properties that are generally associated with the nanometers? You can see nanometers are generally active materials. They show the different properties as compared to the bulk materials. So bulk and nanomaterial, we can compare these two kind of the materials. So there are some different properties associated with the bulk materials as well as some different properties that are associated with the nanomaterials. So we'll see the difference in the next slide. Nanoparticles have generally very small size, just previous slide we have seen, and they have a good surface area. So that are the very unique properties. In many cases, we can see that the nanomaterials are thermally stable. In addition to that, they act as a very good catalyst. So most of the students from the chemistry background are very much interested to synthesize the catalyst and explore this catalyst into the organic transformation or any other applications as a heterogeneous catalyst, as a solar cell material. So these all applications are based on the surface, and every catalyst should be thermally stable, and it should have some unique properties that could be implemented for being a good catalyst. So again, in addition to that, they show some quantum mechanical effect at the atomic and subatomic levels. So that is another merit of the nanometers. At quantum level, they have good electrical, mechanical, and quantum optical properties. So quantum level, generally, you already know what is the quantum level. So that is very small size within the 10 nanometer scale. We can also synthesize this type of material. In addition to that, they are very active in showing a good redox chemistry. So many metal oxides are stable in various oxidation state. That is also important thing as far as the catalyst are concerned. In addition to that, they are exist as a quantum dots. So nowadays we see that there are different kind of the quantum dots and their applications in various electronic fields like televisions or QLED, LED. So that is what the composition based on quantum dots. So multiple applications are there. So we are just discussing here what are the roles of these quantum dots in various electronical fields or technological fields. So we can see that whatever we synthesize the nanomaterials, they have a specific shape, they have a specific dimension. So while synthesizing the materials, we can control the synthesis of the nanomaterials. There are some techniques that are intended to control the shape and size of the nanomaterials. We can do that purposely, but naturally the nanomaterials can gain some kind of the shapes or some kind of the appearance after synthesizing. We can see by exploring some characterization techniques, we are able to see that what kind of the materials are synthesized. So these are the common shapes of the nanomaterials you can see. Different nanomaterials have different shapes depending upon the temperature we applied, depending upon the heat we provided, synthesis time. All these factors may affect on the appearance of the nanomaterials. So nanoflowers, nanofibers, nanoribbons, etc. So there are different shapes of the nanomaterials can be achieved after synthesis. You can see this slide. I have given the alphabetical order and see the A, C, D, G, and H. These are not my images or not synthesized. They are taken from the Google source. But A, E, I, J. These slides are simply the materials which I have synthesized in laboratory. These are the our research, and you can see that the different kind of the shapes that are generally obtained towards the nanomaterials, so nanoflakes, then nanoflowers, nanorods, so nanobelts. There's a flower type of the geometry. So depending upon the agglomeration, depending upon the clustering phenomenon, the nanomaterials maybe have different kind of the geometries or appearance. So you can see that there are different types of the breakthroughs till date in the field of nanotechnology. We have also shown this in our review article, uh, that what are the breakthrough applications of the nanomaterials and nanotechnology in various fields till date. There are different types of the breakthroughs in case of the nano material or material synthesis. So they are the milestones achieved till date in terms of the nanotechnology. So we can see here the difference between the nanomaterials and bulk materials. There are some differences in both this type of the materials. So nanomaterials have the large surface area, whereas in case of the bulk material, they have small surface area. They are chemically more reactive. Here they are some less reactive, faster in performance, etc. etc. So you can see this is a small comparison between the nanomaterials and bulk materials. So in contrast to the bulk material, you can see that the merits of the nanomaterials are quite good in comparison to the bulk materials. So obviously their applications are also have importance as compared to the bulk materials. So there are many terms or there are many definitions, concepts that are applicable in case of the nanoscience and nanotechnology. So most of the time, there is a difference. Always there is a difference. Nanocrystals, nanomaterials, nanorods, nanocomposites. Although these are the very routine terms, but most of the time we don't know what are the meaning of these particular terms. We can see nanocrystals. That is a kind of the material which aggregates in the form of 100 to 10,000 atoms combining in the crystalline form of matter. Generally, that is also called as a cluster. They are larger than the molecules but smaller than the bulk solids. So that are generally classified as the nanocrystals. Whereas in case of the nanocomposite, the material that is made of the two or more substances, and basically these are the particles or materials that are dispersed in a solid phase, and again they have heterogeneous surface. And in addition to that, when we synthesize the nanocomposite material, they can the different uh, compounds may be aligned together with the help of some chemical bonding, chemical forces, or some physical interactions also possible when we synthesize the nanocomposites. So difference between the unit cell crystallites, grains, and particles. When you synthesize the nanomaterial, then the obvious question in our mind that whether this material belongs to the nanotechnology or not, or nanomaterial, we have synthesized this material as a nanomaterial or not. So how to confirm? Basically, that is confirmed from the XRD analysis. And again, the terms that are used here, like unit cells, crystallites, grains, and particles. So there is a small difference between these particles. So basically, unit cells are the smallest among the materials, and followed by the crystallites. Then crystallites are smaller than the grains, and bigger is the particle one. So particle have more size as compared to the crystallites and grains. So whenever we generally calculate the size of the nanomaterial, so that is generally calculated in the form of average crystallite size. And most of the time, students make the mistake there that average particle size or whatever that may be. So generally, from Scherrer formula, we calculate the average crystallite size. So these are the grains particles you can see here. This is one sphere or dot you visible. I am audible to everyone?
Yes, sir.
Okay. So these are the this is actually the TAME image, and you can see that the different agglomerated particles or grains are visible. So this agglomeration is made from the various grains that are combined together, and they are giving together a big size particle. So grains crystallize are the sub categories as compared to the particles. So whenever we calculate the nanoparticle size, the crystallized size is matter in that case. Most of the time, because whenever we choose the topic for our research, and you see that most of the time whenever our discussion is there with the different field persons, so they talk that simply, sir, zinc oxide has been synthesized from last 50 years, and people today still synthesizing the zinc oxide. Then what are the changes they are actually uh, made in that zinc oxide, which was synthesized in 20 years back and today which is synthesized? So we have discussion that is actually the healthy discussion regarding the metal synthesis. But uh, whatever the zinc oxide which is synthesized, that is not going to change. But if you synthesize zinc oxide or any other oxide material that is already synthesized, not doing any kind of the change in that material, then that material is no longer novel material. So making the material novel, some kind of the variety in the material, some kind of the changes in the material. So whatever the changes that are in the various forms, so we generally modify the materials. So modification is very important because whatever the bare materials are, they are also called as undoped materials. These undoped materials are already synthesized. When I look into the periodic table today, so I think that there is no materials left to synthesize for me. Then what to do? Because we have to synthesize the materials, we have to do the research, we have to continue our research. Then we must have some different materials. Explore some different materials that have good properties, that have good applications. And for that purpose, the modification is important. So we can do the modification in nanometers by various techniques. There are different methods by which we can modify the materials. And what kind of the modifications can be done in the material by simply the doping of the nanomaterials. So there are different types of the methods of the doping. Usually you see the research paper, and after reading the research paper, you'll realize that how these nanomaterials are modified by the researchers or scientists. So generally, sometimes they take the some percentage of the metal oxides, some percentage of the transition metal or inner transition metal, or simply the alkali metals or the any element from the p block elements, that may be a non-metal, that may be carbon nitride, boron nitride, whatever that may be. And they're trying to form a different type of nanocomposites. They're trying to form a different types of the variation in the base material and compare the properties of this material. So on what basis we generally compare and how to confirm that the material has been modified. So if the material is modified, so for example, if you dope the zinc oxide by any other transition metal like Ap or cobalt nickel zinc, cobalt nickel or any other material, so there must be some changes in that material. And how to identify these changes? So there are different types of the parameters that we can generally measure, and after that we can confirm that the material has been modified or change its basic properties. So initially, when you synthesize the zinc oxide and simply it is modified by any other transition metals like iron or nickel. So you have now two materials. One is a bare zinc oxide and another is a modified zinc oxide. So modified zinc oxide have, it is possible that the properties are changed. For example, there may be change in the band gap of modified material, that is called as the tuning of the band gap, change in the surface area, change in the crystallinity, porosity may be changed, change in the FWHM values. Actually, they are from the, we can confirm from the XRD, full width of maxima. Conductivity parameters are also changed when the material is modified. Color of the material is also changed. Then bonding of the material may also change. So there are different changes are made, and depending on that, you can visualize the changes. You can simply explore the changes. You can compare both this material in terms of all these things, and you simply report that what are the changes that are made. So that is your simple research. There are many things to do in the research, but basically at very basic level, at a fundamental level, these changes are generally occur, and we can simply overlook into the changes and record these changes and report these changes after modification. So on the basis of that, we can modify the materials in various forms, just as discussed here. So there are many methods for the modification of the materials. So chemical methods, physical methods, biological methods, plenty of methods are there. So as far as the synthesis is concerned, so right from the beginning, there are two categories for synthesizing of these nanometals. Actually, this is also introduced at the BSc level. Student knows that what are the approaches for the synthesis of the material. So this is very famous terminology, top-down approach and bottom-up approach. So you can see this slide. This is very basic concept actually. When you go for the synthesize the material, and that is recognized as a top-down approach. So you can see in case of the top-down approach, that is generally referred as a physical methods, from bulk we synthesize the nanometers. So that is actually in short a top-down approach. So we have a bulk material, and this bulk material is can be converted into the nanometal, and this overall process recognized as a top-down approach. Now, whenever we synthesize the nanometals from very smaller things, right from the atoms, molecules, converted into the clusters, and now these clusters are converted into the nanometals. So that is what the category that can be recognized as a bottom-up approach. So from small to large, from large to small. So this is a very basic difference, and they are categorized into the different chemical methods. So actually, there are three important methods for synthesis of the nanometals. So you can see in short. I hope you are getting this. So main methods of synthesis as far as the chemists are concerned. So because when we were doing research, so we have our friends from physics background, from electronics background, and these people have some problems to synthesize the metals. They know the higher application. They know to fabricate the solar cells. They know to fabricate the supercapacitors. They might be know to fabricate the gas sensors or any other kind of the sensor material or electronic and physical application based on the material synthesis. But the people from physics and electronic background or any other background like zoology, botany or other subject, they have problems to synthesize the materials. And that is very basic problem because they don't know how to synthesize the material, what should be the mole ratio, what should be the stoichiometry of the material, how to perform the doping of the material, what percent should be there for the doping. So these are many questions arise in their mind while synthesizing the material. But although there are different problems, but we have very common methods to synthesize. Although the people from physics, chemistry, or zoology, or whatever that may be the background, methods are same. Methods are not going to change. As far as physical methods are concerned, these are the methods that are generally not possible in our laboratory, college level laboratories. So some universities or some research centers have this. advanced facilities. Although sonochemical synthesis is possible in our laboratory, but mechanical milling, laser ablation, this PVD, plasma jet, cryoscopic synthesis, they are physical methods, and uh, these are quite impossible in laboratory level. But chemical methods are very simple, and they are very easily possible in our laboratories. And chemistry people have almost no problem to synthesize this material. But as we discussed that people from the different background may have different problems while synthesizing the materials. So in addition to that, there are some biological methods are also in addition to the physical and chemical methods. So generally, biological methods are those methods where we generally use the plant extract or some bacteria. People are also using the fungi, algae, etc. What is the purpose of this? So biological methods have gained a good attention of the researchers because of their some biological importance. Some people have the requirement that our nanomaterials should show some biological activity or some variation in the properties. So based on that, they can choose the method that are generally biological methods. But traditional methods are the chemical methods, which are very promising methods to synthesize the various metal oxides. So here you can see the different methods that can be discussed over here. These are very common method actually, but till the uh, researchers have problem to recognize these methods. Whenever we do the synthesis by co-precipitation method, or it is also called as the precipitation method. So in general, the co-precipitation method is very common. We can do the synthesis of any metal oxide based on this method. So that may be transition metal, that may be inner transition metals, that may be some metals belong to the p block elements. So this method is applicable to all those materials which are able to give the precipitate along with the precipitating reagent. So in general, I have also followed this method for synthesizing plenty of the materials during my research. So this is one of the promising and good method, although there are some disadvantages associated. But you see that this method required very simple setup for the synthesis of material. Whatever the oxide you are willing to synthesize in laboratory, that may be nickel oxide, zinc oxide, or any other oxide, that may be inner transition oxide, like lanthanum oxide, cerium oxide, any other oxide. Uh, Initially, we required a precipitating reagent. Most of the time, 1,1 ammonia is also a good precipitating reagent, or sodium hydroxide can also be considered as a precipitating reagent. So, what we are doing here, we are taking some metal salt. So, metal salts are in the form of chlorides, nitrates, sulfate, or any other form. So, this particular metal salts are taken into the stoichiometric amount, and they are supposed to react with the precipitating reagent like NaOH or 1,1 ammonia. Sometimes liquor ammonia is also uh, insisted by the researchers depending upon the alkalinity of the material or requirement of the pH, higher pH. So that is also a very important factor in case of the synthesis. pH is very promising factor for the synthesizing of the materials. So you can take the salts in the various forms, that may be chloride, sulfate, or nitrate, etc. And you simply take the stoichiometric amount of that metal salt, and you add this precipitating reagent to this particular metal salt while continuous stirring. You can see here the magnetic stirrer, and which is kept over this magnetic stirrer. This is actually the nickel oxide synthesis. And during synthesis, you are simply adding some precipitating reagent through this material. You will get here a kind of the precipitate, and this precipitate is actually the hydroxide form. If you take this sodium hydroxide as a precipitating reagent, and after getting this, you will simply uh, do the filtration of this material, and after filtration, you will simply dry the material, and you subject this material to the heating in mobile furnace, either or in open air environment. So this is the simple method. Actually, it requires 5 to 6 hours for the synthesis of nickel oxide. And calcination process is what for 3 to 4 hours, maybe for 5 hours, depending upon the material. So this is one of the method, and that is good method for the synthesizing the materials. That materials are maybe different of your desire, of your choice. You can synthesize. The only condition is that the material should give the precipitate with the precipitating reagent. Another drawback that is associated with this synthesis, if your metal salt containing the impurities, that will also precipitate along with your desired metal oxide. So the material which you are going to use for synthesis there, that must be a AR grade material. It should be free from the impurities. Otherwise, it will also get precipitate and it will show the peaks in XRD or any other techniques. So that will be a improvement. So very promising technique for synthesizing the metal oxides. And you can go for this method for synthesizing the metal oxides. The another method, that is what the chemical method, second method, that is called as the source gel method. And sometimes it is also called as a citrate gel method. So why this method is called as a citrate gel method? Because we generally use here uh, the particular stabilizing agent for the particle is the citric acid, and that citrate actually forms the gel with particular metal salt which we are going to use for the synthesis, and that's why it is also called as the citrate gel method. So this is actually the flowchart you can see for synthesizing the material by soul gel method. What we are doing initially here, we are taking the metal precursor or metal salt, that is also called. You can again take like chloride, sulfate, or nitrate, any other salt, and that should be completely dissolved into the solvent like water or any other solvent. Most of the time, we take water as a solvent because metal salts are generally inorganic in nature, so they are easily dissolved into the water. 100% dissolution is very important of your metal salt into the water. And after dissolution, you simply keep this metal salt solution to the magnetic stirrer and you add simply the citric acid solution of desired concentration. That may be 0.01 mole or zero point 0.1 mole, or whatever your concentration is there, whatever your stoichiometry is there. So you add simply this citric acid to this metal precursor, and initially you see that there is a soul. Means initially when the citric acid is not added, color of your material is different. If it is nickel chloride, then color will be appear as green color. Copper chloride, it will may have blue color, or any other transparent color will be there. But after addition of this citric acid, you'll notice that after some period, 15 minutes or 20 minutes, you'll observe that the color is now going to change. So initially the color is changed, and after addition, continuous addition of this citric acid to a certain limit, 50 ml, 80 ml, whatever the stoichiometry is achieved, so till you'll find that the color is again going to change in most of the material. Because uh, I also synthesize many materials by this method and observe the color, the variation in the particular material. Color change is again the characteristics because of addition of citric acid, and there is a uh, conversion of this sol into the gel is another stage. So after addition of citric acid, you continue the heating. You'll observe that a small coagulation, small agglomeration will be observed among this material because of the heating, and your soul is slowly now getting converted into the gel form. The viscous gel is formed. So the solution, complete transparent solution, have changed color after after complete addition of the citric acid. You observe that now the soul is slowly converting into the gel form. So this transparent or color change solution is now get converted into the gel form. And when this gel is decomposed to the higher temperature, so simply there is a formation of zero gel. And when this zero gel is decomposed or calcined to high temperature, your nanoparticles are formed. So this is a very good method. You'll observe plenty of changes in your material while synthesizing. So this is also very promising method, as well as it is considered as one of the good method for synthesizing the materials. And quality of the material is free from the impurities. That is again one of the quality of the sol gel method. So you can follow the sol gel method. This is actually the image from my research paper. I have synthesized the bismuth nitrate by this method. So this is sol and this is gel, and this is yellow color bismuth oxide material. So you can synthesize plenty of the material by sol gel method. So the citric acid can be used as a stabilizing agent to the materials. Slide is visible. Slide is visible to everyone. Okay. Okay, thank you. So the next method is a hydrothermal method. We can see that what is a third chemical method. So in case of the hydrothermal method, we generally use the SS autoclave here. So this is a SS autoclave. You can design it or you can order from the industries that generally design this autoclave. So in this method, it is half co-precipitation method actually. Till you get the precipitate, it is a co-precipitation method. So whatever the terms we discuss in the co-precipitation, you take the metal salt, you add the precipitating reagent, you will get the PPT. Now when you get the PPT, that PPT you have to transfer into this SS autoclave. And this SS autoclave is simply exert the autogenous pressure when you kept in this particular SS autoclave into the Maple furnace. And you simply subject this SS autoclave into the Maple furnace for certain period. If the it is smaller, some SS autoclave are bigger in size. But calcination is the most important thing to get the metal oxides. So you simply get the precipitate and you transfer this precipitate into this SS autoclave. And after tagging all this particular apparatus, enclose the vessel. And this is actually the wide vessel which is we have kept inside this. And this particular lead is kept over here. And it is completely uh, tight pack with the help of this uh, screw and just kept into the muffle furnace and subjected for several temperature like 400 500 degrees Celsius. That particular water will be get evaporated, precipitate water, and simply you will get the powder form of your material. And again, after drying, you will get your desired metal oxide. So what is difference in precipitation method and hydrothermal method? So hydrothermal method is considered to be a more uh, advantageous method in contrast to the co-precipitation method because uh, when you kept this material into the open furnace, so due to auto exerted pressure and temperature, the particular uh, nanoparticles have a good dimensions as compared to the co-precipitation method. And I also noticed, I have actually compared the same material from the precipitation and hydrothermal. So the desired lattice was obtained after the hydrothermal synthesis. So this is a very good method, but it requires the apparatus. It is a extension of co-precipitation method. After you got the precipitate that is transferred to this SS autoclave and this SS autoclave uh, is simply kept in the muffin furnace and you will get the metal oxides. So this is also a very simple method but require the instrument that is required the autoclave. So another chemical methods that are generally called as the chemical reduction method. So here you can see that the chemical reduction methods are generally associated with the several metal salts which require the stabilization. So for forming the silver nanoparticles, uh, when you convert this silver Ag plus into the Ag, so the stabilization is very important. So for stabilizing, we use generally the some stabilizing agent, as well as initially we have to add the reducing agent. They will reduce this Ag plus into the Ag. Now this Ag after coalescence forms the clusters. After addition of the citric acid, they will be stabilized to this Ag plus clusters or Ag clusters. And now these clusters are converted into the nanoparticles. So chemical reduction method is also a good method, which is also promising method for synthesizing several materials. Not all materials are synthesized by this method. This is limited method for limited materials. So the another method is a combustion method. So this is very less popular method, combustion method actually. Uh, I did synthesis of some materials with the help of this combustion method previously. Nowadays, I am not following this method. There are some disadvantages associated with the combustion method, but still it is a good method for synthesis of the material. It is kind of the soul gel type of the method. But here generally we use a fuel that is called as a fuel. So fuel in the form of glycine or any other material that is able to burn your precursors, and these precursors are able to form the gel. And after formation of the gel, that material is completely combust, and that combusted material is now converted into the powder. So initially, what we do, uh, we simply take the metal salt, that whatever that may be ferric chloride, ferrous chloride, or any other chloride, nitrate, sulfate, etc., and it is combined with the fuel like glycine, and we simply stir that material, and after stirring, the particular mixture is kept for the heating. And while heating, the solid material or that particular glycine mixture with the metal salt is converted into the gel. And when we heat this gel to certain temperature, it is completely combustible. It is reached to combustion state. And sometimes it is also observed that small combustion is observed in the beaker or any other vessel where that materials are kept. And some fumes are generally evolved during the synthesis. Large fumes can also evolve. So after complete burning, we'll get the some dispersed solid material here, and you are able to just crush this material into the mortar pestle. You will get a fine powder. So the combustion method is also good method. Sometimes it is not recommended for those materials uh, which are sensitive to the heat. So large combustion may be possible because of this method. And while combustion, what happens? Some of the material comes out of the vessel, and that will be wasted. So that is the drawback associated with the combustion method. So another method is the solo chemical synthesis. So that requires the instrument, ultrasonic uh, instrument is required for that one, ultrasonic bath. So what is actually the principle of this method? You can see you just kept the material into the vessel, and it is subjected for the ultrasonication. What happens in that? There is a continuous formation of the bubbles. Now these bubbles are slowly grow from small size to the large size, and one stage is reached that these bubbles are simply burst, and whatever the busted bubbles release the energy that is interacted with the your precursor materials, and the energy is provided to that material, and they are converted into the some chemical form. So that is actually the sonochemical synthesis, which requires the instrumentation for synthesis of the material. Now, most of the time, people working on the modification of the material. So whatever the method we have discussed previously, 6 to 7 methods we have discussed, and in that methods you can see these methods are actually for the synthesis of bare metal oxides as well as these methods can also be useful for the synthesis of nanocomposite. So nanocomposite are the modified form of the metal oxides where you can simply add some metal salts to form the metal oxides, as well as you can also combine other materials. We can combine binary metal oxide, trinary metal oxide, tertiary metal oxides like that. Uh, Whatever you desire the compound, you can synthesize. Actually, the nanocomposites are the materials that are how heterogeneous surface and they can be combined along with the metal oxides and other compounds or other uh, salts can be inserted to form the composite material. There are many examples of the metal oxides, but in situ and ex situ, these are the two methods can be categorized. Generally, more popular is the in situ method, where metal salts and dopant concentration are generally considered. So you simply mix, you take the stoichiometric amount of the metal salt, and whatever the element you are willing to combine with this metal salt or composite of both these two, you are supposed to synthesize. So dopant concentration should be added to the metal salt concentration. Follow the methods like co-precipitation, sol gel combustion. Any other method can be recommended here to mix this. And metal salt and dopant concentration will be mixed here after following one of these methods. And you subject this particular composition to the ultrasonication. And after ultrasonication, you simply filter and dry the precipitate subject for the local furnace. And finally, you will get the dope metal oxide. So in case of these dope metal oxides that are generally called as modified metal oxides, or sometimes they are also recommended as a nanocomposite. So there are some properties are modified as compared to the bare metal oxides. So the different forms of the properties can be enhanced here, as well as the bonding between the dopant and the metal salts may be physisorption or chemisorption. So depending upon the type of the material we use, so that these two types of the bondings are possible in case of the nanocomposite. So this is the in situ method. Means while synthesizing, you are adding the dopant. But in case of the ex situ method, you can follow this method. Actually, it is not very recommended method, but most of the nanocomposite that I have synthesized are generally by the ex situ methods, and I observed that there is no problem with the characterization methods while following this method, but that requires some time. So you take the metal oxides, solid materials, you say simply choose here the dopant concentration. For example, you have to dope uh, carbon nitride into the Fe2O3. So you take here this Fe2O3, this is the carbon nitride. You mix this thoroughly into the mortar pestle for 1 to 2 hours, continue mixing. And after a homogeneous mixing, uh, you simply subject this particular mixed phases into the ultrasonic path for at least 1 to 2 hours continuously. After ultrasonication, you have to filter this material and dry the precipitate. Subject this precipitate for heating in local furnace uh, beyond 800 degrees Celsius for 5 to 6 hours. And finally, you'll get the modified dope metal oxide or nanocomposite form. So this is the ex situ method. You are taking here directly the two solid phases, mixing together, ultrasonication, local furnace, and you'll get the modified form. Here, what is difference in situ? You are taking this metal salt solution phase you are mixing or following one of the method, and after getting this ultrasonication, drying, you will get the calcination and you will get the final compound. So only difference is that here you are taking the metal salt and dopant into the solution state, and here you are taking it to the solid state, ex situ method. So this is the difference. I have followed both these methods. So we can do the characterization. So here I'm just exploring that what kind of the methods that are generally useful for characterization of the materials. Those people who are working in synthesis of the nanomaterials, nanocomposite or any other solid materials. So they are very popular techniques for synthesizing the materials, sorry, characterizing the materials. So XRD means I think they are very popular terms as same, then TAME, EDS, BET, UVDRS, XPS, Raman, DLS, AFM, PSM. You already familiar with this one. I think you are familiar with the XRD same time, but these are quite advanced technique like BET. There is a Bronet, Emmett, Taylor. There are the three researchers who develop this technique for surface area of the material. We'll get the pore size, pore distribution, in surface area, everything you will come to know by this bed. EVDRS will go to the, you will conclude about the band gap, direct, indirect, as well as photoluminescence is also recommended for this band gap prediction. This is another advanced technique that is called as X-ray photoelectron spectroscopy. Generally, that is useful for the chemical composition to find out the oxidation state of the material. For surface entities, you will take the XPS. Raman is also, you know about what generally we get from the Raman. Then another one is the DLS, dynamic light scattering, atomic force microscopy, vibrating sample magnetometer. So there are the different techniques. Depending upon the requirement, you can choose this technique. So what you get from the XRD? Generally, when we plot the XRD, that is against the two theta values, against the intensity or uh, counts. So the graph generally compared with the JCPT's card numbers. So that is Giant Committee on Powder Diffraction Studies. So JCPTS is the generally data that is mm, already taken for the materials. So plenty of materials are already synthesized. You are not doing very novel things in the materials. Suppose that AP304 you are going to synthesize, and this is the JCPT's card number. So what is actually this JCPT's card number? That is actually indicating that for AP304, uh, how many peaks should be obtained and what should be the two theta values, what should be the HKL planes, and everything about the particular material. So when your peaks are matches with this JCBDS number, so that assuming that your material has been synthesized. So this card number is unique for every material. We generally give this number in a research paper. So reviewers are also asked about this JCPDS card number, whether you have compared your material with the JCPDS card number or not. If it is not available, then there are many objections for your material. So the JCPDS card number is very important for synthesizing the materials as well as for reporting the material in terms of the publication. So basically, from X-ray diffraction, you are getting the crystal structure, you are getting the composition, you are getting the average crystallite size. There is a spelling mistake. There should be crystallite size. Crystallite size. So these are the actually parameters that you generally get from this X-ray diffraction data. In addition to that, you can find out many properties from the X-ray analysis. So microstrain, age dislocation, many X-ray diffraction density. So many things can be investigated using XRD data. So that is very, very useful tech. Those people who are working in the materials, for those, this is very, very essential technique and how to interpret the data from XRD. You must learn this technique about the investigation. Plenty of videos are available on the YouTube. You can explore these videos. Many of the researchers are explaining about the XRD, how to plot the XRD, what are the softwares, what are the parameters that should be we consider. So plenty of the researchers are available on your fingerprints. You just go to the internet, you can see the videos and you can get the good information. So scanning electron microscopy is another useful technique where you can explore the morphology of the material as well as the surface texture, then porosity of the material, surface area, as well as how the surface is looking, how the particles are looking, and whether the voids are present, cavities are present, appearance of the material, everything can be visible from the scanning electron microscopy. More advanced, more resolution, more high power resolution is from the tail. You can directly observe the lattice, whether the material is in agglomeration state, etc. That can be identified from the tail. So topographical properties are generally investigated from the tail. From EDS, you are able to visualize the elemental composition. If you take the material as a zinc oxide, so what is the composition of your material, weight percent, etc. We'll get from the same, as well as at what uh, actually this technique utilizes the binding energy of the material, and this binding energy is calculated in terms of the electron volt, kilo electron volt. So these are the particular peaks are generally fixed at particular level, kilo electron volt. So they are generally identified from their binding energies as well as this kinetic kilo electron volt values. So these are actually very big techniques, not summarized into this 2 or 3 minutes like half-hour lecture. I think there should be separate lecture on these separate topics. UV-DRS is also ultraviolet diffuse reflectance spectroscopy for the band gap, for optical properties calculation, etc. You can explore. This is the very advanced technique for elemental analysis as well as oxidation state observation as well as from the surface characteristics, that is X-ray photoelectron spectroscopy. All these images I have put from our research paper only. So these are our own research and our own graphs. So another technique, there is the DLS, that is called as the dynamic light scattering. Actually, you send the sample, solid sample, and that analyst will use some appropriate solvent, and after subjected to the DLS, you will get the zeta potential of your particles. So zeta potential implementing that what is the stability of your nanomaterials in the colloidal state. So zeta potential values are different. That is from positive to negative values are there. And depending on that, you can make the conclusion if the values is within this range, stability, medium stability, good stability, whatever that may be. So that DLS can also be useful for confirming the stability. This is VSM for magnetic property. So there are plenty of applications of the nanometals. So this is the lecture based on the synthesis properties. If there is any question on this topic, you can ask me. I have one more topic for 15 to 20 minutes. I will summarize that topic and then we'll stop after 20 minutes, I guess. If there are any questions based on this topic, we can ask. Any question?
There is one question, sir, in chat box. Please see it.
Yes, yes. So basically, AFM, based on the question, there is atomic force macroscopy. So it is actually very less useful technique as far as the nanometals are concerned. But if some has to explore beyond the topography, like what are the friction forces in your material, what are the electrical forces in our material, that can be explored with the help of AFM, that is the atomic force microscopy. So additional properties beyond the topography, like surface, then size of the material, uh, as well as lattice of the material, they are generally confirmed from the same and tail. But beyond that, the friction forces, electrical forces, then magnetic domains generally confirmed from this AFM. Next question is, I think, how to say that substance is magnetic or non-magnetic on which criteria? Okay. So magnetism is generally confirmed from the VSM analysis. That actually we don't have that much time to talk on VSM. But if you are thinking that your material is magnetic, then you can send your sample for the VSM characterization technique, and that analyst will provide you the data based on your material, and the hysteresis loop will be observed there. And the hysteresis loop is observed in your material, this type of the hysteresis loop, suggesting that your material is magnetic. So depending upon the what is magnetization induced in your material, what is saturation limit, what is coercivity, what is retentivity, all these parameters generally given by the analyst, as well as what kind of the magnetic field can be penetrated, what is the saturation limit to penetrate the magnetic field in your material. So all this information can be given by the VSM analyst. Any other question? Okay, I think there are no further questions. Okay, going further to explore the another topic. I hope you are getting this lecture. Is there any problem? Sir, I think we have more half hour, right?
Yes, sir.
Okay.
होस्ट आहेत का आजचे ढवळे सर?
Yes,
Hmm.
sir. Yes,
सर
sir.
सेशन झालंय?
अजून घेणार आहेत सर थोडं.
तेच म्हटलं आहेत का नाही?
Yes, sir. I am
Yes,
here.
घेतायत
Hi,
सर.
sir. You are not there, but I am here.
हा तेच म्हटलं काय?
Okay, sir. So this is another topic to talk here. That is a effective strategies for you article writing. So we'll try to summarize this topic in next 20 minutes. So there are different types of the articles when we do the research, and while doing the research, everyone is willing to communicate their result to the society and to publish their data into the reputed journals. So what is the need to publish? Why we publish our data? Anyone? Okay. So there are many research in history. You know that we are not very big research. We are not doing very extraordinary research actually. Whatever we are doing in the laboratory. But previously, you see that for sharing of the knowledge. Yes, that is good answer from participant. So previously you say that there are different types of the researchers work on different fields, and whatever they have worked, they have communicated their research to the society for the beneficial, for actually the cause of good sake, or for that particular research should be useful to the society, whatever that may be in terms of the medical terms, in terms of the different works that they have reported. For example, simple antibiotic penicillin. So whenever that was synthesized or accidentally it was synthesized, but if that was not synthesized by Alexander or that was not reported, then what would happen? If I am doing some extraordinary research, I am not telling this research to the society, not telling this research to the government, then what will be the use of that research? So the most important thing is that whenever we are doing the research, and if it is beneficial to the society, so that must be communicated and that must be announced to the society that so and so person has worked on this topic. So to gain the attention globally, to recognize your research globally, we generally publish our data in various international databases. So that is the most important thing. And no doubt there are some research that are not for publication, like our defense services or any other services. But for the betterment of society, when we do the synthesis or when we carry the research, and if it is of prime importance, then that should be communicated in various forms. So that is the use of publication. So publication generally we can do in various forms, like a original research article, writing the review article, short communication, case studies. So there are different forms of the articles. But specifically, as the organizers has given me the permission to talk on the writing the review article, as well as I am going to explore how to communicate your research article to the reputed journals. What are the different stages for the communication? So when you think about writing the research article and communicating this research article or review article to the any kind of the journal, and the new researchers think that what to do, how to do. There are plenty of questions in his or her mind, and they are completely confused that how to communicate this particular article, what are the stages, how could I recognize my research at the international level. So there are plenty of questions, plenty of problems, and most of the people are hiding the true things. I just observed that many times. They are not in a mood to tell the new researcher, they are not in a stage to help the new researchers, budding researchers. And because of that, many researchers face the problems. And obviously, it is not good thing. But if we have a good knowledge, we can share the knowledge. And depending on that, the new ideas can be developed among the researchers. So that is again very good thing. Because as far as the communication is concerned, we can communicate our research. So whatever, I think all these participants that are joined over here that are doing their research, when long back in 2015 I registered for the PhD. I completed my research in 2020, and I realized that actually uh, one must write the review article based on our own topic. So what will be the benefit? What will be the importance of that? While writing the review article, you'll get plenty of knowledge about your own topic. There will be no extra need to pay the attention on your topic to get the information to explore the things. So it will be my request to all of you if you are doing a PhD, then try to write at least one review article based on your own topic. So that will summarize your introduction, literature review, everything, and you'll come to know about thoroughly about your topic. So review article writing, there are many advantages to writing the review article. First of all, you will get plenty of knowledge about your topic. Second thing, you will get that the you see citation database of the researcher, and you'll observe that for review article there are many citations always, because review article comprises very thorough information, and most of the time when we download the research paper or review articles, you will get mm, good information from the review article. So that is a very important point, and for that purpose, everyone must write review articles. So there are different stages in case of the review articles. We'll summarize in very short time. Actually, it is already 1 hour and 15 minutes. We are, I'm conducting this lecture, but okay. There are different types of the articles. See the short communication, original research article, and review article. So as far as the short communication is concerned, there are some publications, they have very strict mindset about publication. So whenever there are some journals, they are starting with the name like uh, tetrahedron letters, inorganic communications, or proceedings. So these are actually the journal that are willing to publish your research article within very minimum pages. Very least data they require, least but quality data they require. So you should summarize your data within 8 to 10 pages. Whatever the important things are there that are generally only kept in your research. So that can be communicated to the short communication. So these are actually the very rapid publication. Many times short communications are published in shorter period, and they have again given uh, complete guidelines to publish your articles to summarize your data. And this is again very good source to publish your articles. Most of the time, what is the importance of short communication? Suppose that you are conducting a research or you are doing research on one topic and you are thinking that this research will take at least 2 to 3 years for a complete work. And if within that time, if some researchers is doing on the same topic and if he publish that idea, then your research has less importance because someone has already published same data. So for avoid this type of the things, you can do a short communication before complete publication of full original research article. You can do a short communication within that period, 6 months, 1 month, 1 year. You conducted the research, whatever the things you know, you just summarize and communicate to a journal within 6 to 8 pages, within 8 to 10 pages. So that will be the beneficial for you, and the credit of that research will be on your name. So that is the importance of short communication. Now, as far as the original research article are concerned, these articles take time. Uh, if someone is willing to publish his or her article as original research article, so there should be a plenty of data. There should be a thorough discussion. There should be a novelty in your research, and that original research article maybe ranges from 10 to 30 or 40 pages, depending upon the choice of the journal or acceptance limit of the journal. So original research article contains all the things in a comprehensive manner like abstract, graphical abstract, everything research highlight, introduction, materials and methods. So this is actually the standard uh, set for writing the article. When you go to the website of the journal, you'll observe that the journal has given already the guidelines to publish your article. You have to read that guidelines and prepare your manuscript accordingly. So that is the most important thing. But original research article takes time and based on your own research that you conducted in the your own laboratory or in collaboration. So the review article is quite different thing as compared to the short communication or original research article. Because for review article, it is not compulsory that you must do the laboratory research. For writing the review article, you need one topic in your mind. That may be your PhD topic, that may be a topic of current investigation, that may be a topic of very importance. So you can choose any topic from past period, from present period, or uh, that may be the topic of investigation. So simple chemistry people can choose the topic of what is the importance of carbon nanotubes, past, future, and current trends. You can choose any topic. Any organic people can choose any Bignelli reaction or any other reaction. Botany people can choose any family. What is the past of that family? What are the different classification based on that? So topic is any topic based on the your idea, based on your choice. So review article has a need of first initial, that is a topic. Then you can go for it. So there are again two types of the review articles, that short review article and long review articles. So sometimes it may happen that if someone is willing to publish the review article based on the current investigation, like 10 year back. But suppose that I am willing to publish the review article from 20 to 30 years, 40 years back, what people did in past on this topic. What is the scenario of this topic, right from the history to the present. So 30, 40 years data can be comprised, and that review articles may be ranging from 20 to 100 pages, that long review article. And short review article may belong to the 10 to 20 pages, depending upon the data. But it containing the limited information, short review article. Whenever you go for the long review article, it contains the thorough information about the topic you chosen. So that is the difference. So long review article again takes the time. There are many things associated with the long review article. So there are different types again in case of the review article, that literature review, systematic review, critical review. So depending upon your topic, you can choose this type of the materials. So I'm not going into that detail about the impact factor. You already know how to calculate the impact factor. Most important thing is that citation. I think no. For science people, the most important thing that try to publish your data into the science citation index. That is called as the sci journals. That is a top quality indexing in terms of the science people, science research, or science citation index expanded, that is SCI. So these are actually the fields for the science, technology, engineering, medical, agricultural field. That is SCI, and Sci journal is very reputed journal as far as the science people are concerned. So the impact factor already know that number of citations received by the journal in last 2 years, and total number of published paper. Depending upon that, the impact factor is calculated. Another important thing is that the abstraction and abstracted and indexing is again important thing. You can see that while publishing your article, this indexing is very important. Suppose that I am going to explore one website. Screen is visible.
Yes, sir.
Okay. So see, this is a journal from the Springer publication, Optical and Quantum Electronics. So you can see about this journal, you can read what is the information, who is editorial board, what are the policies, rights and permission, overview. You can see, you can read that this journal publishing what type of the topics, what kind of the information uh, they generally want from the researchers. So that is what the important point. And based on that, you can choose the journal. Here, everything is given that what is the impact factor of the journal, 5 year impact factor, how many downloads, and the editor in chief. There are the different latest publication. Again, go to the down, you will see the what is the indexing of this journal. This is the most important thing as far as the journal is concerned. You see that the journal information, that is electronic ISSN, International Standard Serial Number, that is a publication online. This is a print ISSN. Based on the publication hard copy they publish sometimes, if the researchers are required, then the print ISSN is different. So this is the abstraction indexing. You can see that what is the journal is abstracted in. What is abstracting actually? Google Scholar, see, Google Scholar has given indexing to the many journals. Means if the papers are published by the journal, so that will be automatically recorded into the database of the Google Scholar. So that is called as a indexing. So most of the time you see these are the different. I think Scopus is also there. Scopus is not there. Chemical Abstract Service, Scopus, Web of Science, like that. So that is the uh, different types of the database. So the abstraction and indexing is very important thing uh, as far as the journals are concerned. You see where the journal is abstracted. Now another important point that are the different quartiles are generally associated with the publication. Q1, Q2, Q3, Q4. The most prestigious journals are generally kept into the Q1 category. Top 25 journals in various fields. They are having high impact factor, more than 5 to 10, ranging at least 5. Limited is a 5. And after the impact factor of 5, they are generally categorized into the Q1, that is quartile 1 journal category. Second quartile generally below to the impact factor 5. So the Q1 journals are ranging from 5 to 100 impact factor. Okay, you see that there are different journals which are having impact factor nearly 150 to 180 like that. So we try to publish. We are very fortunate that if our publication is published in 2 or 3 impact factor, so we are very happy. But see, the journals having very high impact factor, right, from 5 to 100 to 150 like that. So Q2 journals, Q2 is another category which consisting the journals of quality reputation below to the five impact factor. And again, below to this category, Q2 category, there is a Q3. And the list 25% bottom journals are included into the quartile 4 category. So indexing and citation database, everything, depending on that, the impact factor, downloading, etc., decides the quartile of the journal. So this is the manuscript preparation for the review article. You have to formulate the problem. You just choose the topic and use the SciFinder website for choosing your topic, whether the same work has been published or not previously. So you can choose any topic, just I told you previously. Do the literature survey in various database sources like those Google Scholars. There are plenty of the literature survey sources are available online. And you can download the research paper from this database and gather the information from all these databases. Most important thing I'm going to tell you in the next slide. So these are the database. So free publications or some open sources are available from which you can download, but some research articles are not freely available. So for that, subscription is important for your college library or for your research library institute, so that you can download these research articles. So that is the important thing. Uh, if you doing the review of any reputed journal, for example, I am the reviewer of many elsewhere journal. I reviewed many manuscript. So what is the benefit of that? So your review record is directly updated to the ORCID database. First thing, you you become expertise in that field. And third important is that from 2020 onwards, one of website is there that is called the SciHub, from which we can directly download the research paper. But nowadays it is not possible to download the latest research paper. If I am the reviewer of the Elsewhere journal, and they simply provide the 6 month complimentary access to all the Elsewhere journals. So whatever if the paper is published in the today date, I am able to download that paper because I am the reviewer of the Elsevier publication. So they have given me, they have granted me the access to download the any paper which is published till date. So that is the benefit to become the reviewer of the standard journal. So you will be updated, you will have plenty of resources, and you will get a good information about the latest published articles. So that is what a important point. So preparation of outline is very important point. This is one of the review article that we have published along with my friend Satish Aire, who's already working in your institute, Panchvati College. So we have published one review article. I think 100 citations are crossed for this review article, which is published in 2022. So outline preparation is very important. Abstract keywords, introduction. You can mix many compartment in the introduction depending upon the technology or depending on what the information that is available with this material. And as this article is based on basic information of the nanotechnology, we have categorized this material. We have categorized many things into this outline. So as you are thinking that what kind of the outline will be there and what important points can be summarized. So you can summarize. So there is no limit for the review article. So depending upon that, you can make the topic of your choice. Simply, sometimes editor will advise you if you communicate this paper to the journals. But whatever the your mind thinks that this topic should be covered into this review, you can put this topic. Current investigation, past investigation, what are the breakthrough applications, what are the future trends of your topic, what will be the scenario in the next 10 to 8 years. So that everything is can be included in this particular review article. So we know that the abstract writing is important for research as well as review article as well as short communication. So that is a very summary of your important findings, important highlights, and your future scope also can be highlighted into this abstract as far as the review article is concerned. So introduction, I just told you that you can make the compartments into the various section. Uh, you have to write the very thorough intro, impactful intro that can attract the researcher or readers from the different fields. We have to write down some previous reported work from beginning to till date, if that article is a long review article, you have to divide this particular section into the various important section. We have to draw the figures, tables, etc., depending upon the demand of the topic. Now see, we have to give the quality images that are having a very good high resolution. These are actually our own research images. The most important thing, if you are writing the review article, some of the people I think already aware about the plagiarism. And plagiarism is what you simply putting the already published information without any prior permission of that researcher or a database or website. So that will be called as a plagiarism. If you are not taking any permission of the original researcher who has written that article, who has written that database, so that will be categorized as a plagiarism. So for your article, you have to take the permission if you are willing to put the images that are already published by someone else. So you just mail to the corresponding author that we are writing the review article, and for that purpose, we just want to take your images that are already published in your so and so research. So that corresponding author will give you the permission, and after that permission, you can put that image directly, but you have to put one reference that with the permission of this and this author, which is published in this data. After taking the prior permission, we have added this image. So that will be not comes under the plagiarism. But if without any proper concern, if without any proper permission, if you are directly adding the published data, then definitely that will becomes under the category. I think you already nowadays you heard about the uh, retraction of the research article. So retraction is what simply your already published data is rejected by the journal. So that is what the retraction. So if you are willing in future this type of things should not be happen with all of us, then we should take a very proper measure while publishing a review article or research article. So referencing is very important. Proper permissions are very important, and without that permission, we cannot use any published data into our research article. So that are very, very common ethics in the research. You must follow all those things. So this is very, very important because retraction is now increased. Journals think that these images are already taken by someone researcher and these are replicated. So they will simply retract your research. So our whole uh, importance and our dignity will be lost in that case. So we should take care of all those things. So this is what the thing I was talking here. Permission of reproducibility or already published research data from the review article. So this is the most important thing. Authorized sources, we have to take the permission, and after prior permission, we can add that particular data. Because when we write the review article, we need some database. And without the proper permission, we cannot add this database. And if you are adding, that will comes under the plagiarism. So all these are the important point. Materials and methods. Elaborate the importance of your presented work. Prepare the good summary. Prepare good conclusions. You have to take the feedback of your review from your co-authors, which are contributing for that. And the referencing also should be prior. You can also use the Google Scholar citation style. I think you already know about that. How to do the Google Scholar citation style. If you don't know, you can explore here within 1 to 2 minutes. So suppose that I am able to give the referencing for the any article. You can use the Google Scholar site here. So just click here on the double inverted comma. You'll get the referencing style from Harvard or Chicago like that. You can directly copy and insert into your research articles. So another softwares are also there like Zotero or uh, another referencing tools are also there. You can use that EndNote or Zotero like that. Google Scholar is very easy for that. You can also do the literature survey with the help of Google Scholar. So this is very this is a summary where you can prepare your manuscript, important points. You can also take the information from online sources to prepare the review article. The review article preparation requires very long time, at least 1 year. I think we took 1 year to mm, gather the information of that review article, and after that you finalize. So review article writing is not very easy task. You have to take the permission, you have to take the prepare the database, you have to prepare the draft, then summary, everything. So that is critical job, but that is beneficial. So plagiarism check, there are different softwares where you can check the plagiarism, grammarly, turnitin, like that. There are different softwares. So I'll advise you that you should check your plagiarism and then submit your manuscript to the journals. Because initial phase, when our paper goes to the editor will, before going to editor, it will go to the technical checking. But technical checking is actually how you have written the paper, how many grammatical mistakes are there, how you have constructed the sentences, what is the body of your research paper or your article, is there any plagiarism, or the similar article is published. So this is all the technical checking. And after technical checking, your if it is passed in technical check, then it will go to the editor. And then editor will see your paper. If it is good, then it will go for the review process. Otherwise, editor may reject your paper at the editor desk level. So these are very important things that your paper should impress the editor. And after that, that paper will definitely, if it is going for the peer review process, so there are 70 to 80% chance that your article may be accepted for the publication. So editor will decide whether it is good or not for that journal. So this is the basic difference between the research article and review article. The communication of the review article to the reputed journal is another important task. Most of the people doing the research don't know, they are just listening, and they become the target of the predator journals. I think you know about the predator journals. So those journals which take the money from you for publication, that are comes under the category of predator journals. So to avoid those things, if your research is good and you think that my research publication can be published in a reputed journal that has a good indexing, that has a good impact factor, that has a good readers and everything, good database. So you can think that the for the good publication. And for that purpose, you have to choose the journal. That journal choice is again important point. But this is the editorial manager where you have to register. And after registration, you can put this username, password, everything, and author login. And the window will be pop up where you can submit your different documents like manuscript, then letter to editor, conflict of interest statement, figure, table, everything that will be summarized over here. And after putting some information, your paper will be communicated to the journal. So that this is again a very long process. I am not going into that detail. It will take at least 15 to 20 minutes. So there are different types of the communication types of the research articles. So you see that there are two types of the uh, communication: review article or research article or communication. Same uh, parameters are there. Open access and subscription. Sometimes you see that if the article is published in very reputed journals or very reputed publication, like Elsevier, Taylor Francis, Springer, American Chemical Society, RSC, whatever that may be the journals. And when you go to the searching of the any research paper, and you simply type into the Google, give the research paper based on this and this topic, and after that there are plenty of research paper or pages will be appear, and you just click on one paper and simply it shows that this article is not freely available. So why it is not freely available? Because that is actually the not published under the category of open access. If that particular research paper is published into the category of open access, then and then it will be freely available to all of us. But if that research paper is not published under the open access and it is published as a subscription, all the rights are generally reserved by the journal or publisher. In that case, we have to either subscribe that journal into our college library or enlist or any other sources. We have to pay some subscription charges monthly or annually to that journal, and then we are able to. Yeah, yes, yes. Okay, sir. So there are two types. So if that paper is published into the subscription category, then we are not able to download that article freely. You have to pay the charges. And open access is another category where if you have funding of research, then you can pay the open access charges to the reputed journals also. That charges are very high, 1 lakh or 2 lakh in dollars. And after that, your research is freely available to everyone into globally. Anyone can download. Your research will be reached to the maximum number of peoples. So another part which is associated with the subscription, that is the embargo period. So that is embargo period is actually the period that is reserved by the journal. Up to that period, the journal is not giving free research paper to anyone. So the embargo period may be variable, 1 year, 2 year, or 3 year. After over of this period, if you have published your article as a subscription, then it will be again available freely to all of us. So that is what the embargo period. So embargo period is simply the period of the journal where that is reserved by the journal. In that period, no one will be able to download the research article freely. After finishing this embargo period, the again that article will be freely available. So that is the embargo period. So there are some databases where you can find the best journal for your publication. For example, if someone is willing to publish the research paper in elsewhere journal, so here you can use this source, Journal Finder. So just put here your abstract, and after putting that abstract, there are plenty of journals will be available. Find journals. The list will be appear. That list will also tell you that what is the percentage, what are the chances that the journal may accept your paper. So this is another source where you can find the journals. The different publication have different database, Springer, Taylor and Francis, Willey, etc. So this is the small difference between the Web of Science and Scopus. You can see Web of Science is specifically for the science publication. Scopus is for book that is owned by the Elsevier and this is owned by the Collaborate. So thank you very much for your patience listening, all the audience. And I am also thankful to the LVH College Panchayoti Nashik for providing this opportunity me to put my views in front of very wise audience. Thank you very much.
If any question, please ask. I would like to express my heartfelt gratitude to Dr. Prashant Kori sir, Honorable Principal, Faculty Member, and Research Scholars. Sir has explained nicely the techniques for nanomaterial synthesis as well as a research article writing, particularly a review article. And I think all of us will benefited from this. So with this, we conclude today's second session. Thank you, everyone. Thank you, sir.
Okay, okay. Thank you, sir. Thank you. Have a nice day.
Okay,
Thank you,
thank you.
sir.